This is the cityscape of London at night, and this is a good backdrop for this lecture on the environmental impact of using fossil fuels such as coal and petroleum. Human society runs on energy. Coal continues to be the major energy source for meeting the electricity needs of the world. And you can certainly see from this image here that we as humans consume a lot of electricity. Fossil fuels such as coal, crude oil, or petroleum, depending on what you want to call it, and natural gas, which is mainly methane, which is an organic molecule, CH4. All of these are organic molecules. They've been formed from natural processes, from the heat and pressure of the earth. These were once living organisms. And over hundreds of millions of years, largely microorganisms and plants were converted into hydrocarbons that we can burn. And when we burn them, we can produce heat, and we can also produce electricity to meet the needs of our economy. We call these resources non-renewable because it took hundreds of millions of years, sometimes more than 500 million years, for these fossil fuels to form. And we as humans consume them very quickly. In fact, we really started consuming them in about 1800 with the Industrial Revolution. And over the last 200 years, we have used most of these resources, and most experts will agree that probably within the next 100 years, so maybe in your lifetime, certainly in the lifetime of your children and grandchildren, we will most likely run out of these fossil fuels, and we will no longer be able to depend on them to meet our energy needs. The process of burning these fossil fuels contributes to things like climate change. They also introduce a variety of different pollutants into the atmosphere, such as nitric oxides, sulfur dioxides, lead, mercury, other types of materials that are not good for organisms living on planet Earth. You can see from this slide here that not only does the burning of these fossil fuels contribute to environmental damage, but the mining of these fossil fuels also contributes to the destruction of the ecosystems on planet Earth. This is an example of what happens when you go into an area. This is from West Virginia, so this is in the Appalachian Mountains, which has a large deposit of coal. And in order to get to this coal, they will use this technique called mountaintop removal, where they will quite literally cut off the tops of these mountains to get at the coal seams. This dark material here would be the coal, and that's what they use for energy production. Once these mountains are removed, they are not replaced, and you can see that these are very vast areas, and we'll see some satellite images to show how destructive this can be for the ecosystems in Appalachia and elsewhere around the world where this technique is used. This is coal. Most of you have seen this black material. This is anthracite coal. If we look at it, if we break this down and look at its molecular structure, this is what it would look like. Each point on here where these lines meet is carbon. So this is carbon, 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 carbon. All of these intersections are carbon. So you can see the vast majority of this material is carbon. This is a mineral. We can burn this material and again generate tremendous amount of energy from that we use to produce electricity. This sedimentary material also contains oxygen, which you can see right here, hydrogen, which you can see right here, sulfur, which you can see here, and nitrogen. They have trace elements associated with this coal as well. So in throughout here would be arsenic, chromium, mercury, selenium, all of these other trace elements that occur naturally with coal. So anytime you mine this material, these elements are going to be brought up to the surface, and they're going to get into the watersheds, get into the drinking supplies, and cause problems. And when you burn this material, this is how things like mercury are released from coal-fired power plants, because that mercury naturally exists in here, and when you burn that material, some of it goes out of the stack. Since this is mostly carbon, when we burn this material in a coal-fired power plant, it releases that carbon in the form of carbon dioxide, and this is a greenhouse gas, and this is why coal is responsible for a considerable amount of the greenhouse gases that we have in the atmosphere today, because we burn so much of it to produce electricity. The majority of this material is carbon, and when we burn these carbon compounds, it converts it into carbon dioxide, which goes straight out the smokestack into the atmosphere. Coal is referred to as a sedimentary organic rock. It contains somewhere between 40 and 90% carbon. The more carbon it has, the older the coal, and when we burn it, we can get hotter fires. We can generate more electricity from that. Coal itself takes hundreds of millions of years to form, and it goes through different stages. It begins as peat material. You can burn peat, but you're not going to generate enough energy from that. And so coal-fired power plants today do not burn heat. Over millions and millions and millions of years, this peat, through natural processes of pressure and temperature, is converted into the harder black coal that we burn to generate electricity. Coal itself can vary in the amount of sulfur that it has. Coal with high sulfur content formed in saltwater marshes, and so the bacteria living in there in these swamps converted the sulfate in the seawater into minerals such as pyrite, and this became incorporated in the coal. And so when we burn this high sulfur coal, we're going to release more sulfur dioxides into the environment. When they get up there, they can lead to things like acid rain and the formation of sulfuric acid, which leads to lower pH in ecosystems where this rain falls and can cause a considerable amount of damage to organisms living in that area. In the United States, coal in the eastern part of the United States is about 300 million years old. This was around before the dinosaurs. In the western part of the United States, in places like Wyoming, this is younger coal. It formed about 150 million years ago. The formation of coal itself is quite simple. You start out with living organisms that were on planet Earth 300 million years ago. These include photosynthetic plants and photosynthetic microorganisms. They're taking the sun's energy and through the process of photosynthesis converting it into glucose. You and I can eat this glucose to get the energy we need, or when this vegetation dies, it will settle to the bottom of these pools and lakes. It becomes a very oxygen poor layer. We call that anaerobic. And then over hundreds of millions of years, a coal seam is going to form because of the tremendous pressure that's going to build up from the overlaying layers of material. And it's going to be very hot in there in these conditions, and this is going to lead to the formation of the coal that you and I can then burn to turn on the lights. Coal itself, as we mentioned before, takes up to 500 million years to form. In Appalachia, this coal took about 300 million years to form, and in the western part of the United States, about 150 million years to form. And so, again, this is why it's referred to as a non-renewable energy source, because when we're done consuming this fossil fuel in the next 100 years or so, we will have no more. If we want more, we're going to have to wait 500 million more years, and that's a very long time in terms of human evolution. We know from previous lectures that humans, or early hominids, have been on planet Earth for maybe 5 million years. And so we're talking about some process that's going to take hundreds of millions of years beyond that to replenish these resources. So this is not a reliable energy source for future generations of humans, and we're definitely going to have to move from something other than fossil fuels to meet our energy needs. The other thing that we're going to talk about is energy return on energy investment. And what this looks at is more of a business standpoint. If I'm going to mine this coal and I'm going to burn this coal and generate electricity, I need to generate more energy and more money from burning this coal than it actually took to mine this coal and bring it to the power plant. If I'm not making a profit on that, I'm not going to mine this coal in the first place. And so we're going to talk about what energy sources are better for investing in, because if they're just not a good investment, they're not going to be mined because you're not going to make a profit off of it. There are different types of coal. Peat and lignite are very young coals. You can burn them, but you're not going to generate a lot of energy from this. So we're not using this material in coal-fired power plants. Bituminous and anthracite coal, this is much older coal. This is a few 100 million years old. It's very dark. You can see here that indicates that there's a very high carbon content, and so we can burn this material and generate a lot of energy from this. Again, peat and lignite are very young coals. When we burn this material, we're going to generate energy, but just not enough to be profitable. When you compare these different types of coals, we can compare it by the amount of energy that they're going to produce. And I think a lot of you are familiar with BTUs, or British thermal units, and this is just a way that we measure energy production. A BTU is the amount of energy that is required to heat 1 pound of water 1 degree Fahrenheit. And you can see here with the bituminous, the subbituminous, and the anthracite coal that you can release up to 23 million BTUs per ton. Bituminous is about the same. Subbituminous is about a little bit less, 18 million BTUs per ton. So if you want to make a profit, if you're a company like American Electric Power, these are the coals that you're going to want to mine. These are the coals that you're going to want to burn. They have a very high carbon content. When you compare this to something like lignite, again, 13 million BTUs per ton is about half, not quite half of what it is for something like anthracite. So again, when you burn this material, because it's mostly carbon, you're going to, through the process of combustion, convert that organic carbon molecule into carbon dioxide, which is a greenhouse gas, and this is going to be introduced into the atmosphere and likely contribute to climate change. In the United States, coal that is mined from underground mines or surface mines account for about 60% of all coal that's produced in the United States. It may surprise some of you, but the top coal producing state today is Wyoming, followed by Kentucky and West Virginia. This is the bituminous coal that's in Wyoming. It's about 150 million years old. In Kentucky and West Virginia, this is from the Appalachian region. This is older coal, about 300 million years old, and so it's going to have a little bit higher carbon content, and it's going to be something like anthracite coal. The coal from Wyoming has a sulfur content of about 0.35%. The coal in Appalachia has considerably higher sulfur concentrations. As a result, when you burn this coal, you're going to produce more sulfur dioxide waste, which can go up into the atmosphere, combine with water vapor, form sulfuric acid, and you get precipitation, acid rain. And so when you burn coal at a coal-fired power plant from coal that's from Appalachia, you're going to have to use different technologies to remove that sulfur so that you're compliant with the Clean Air Act and you don't release this material into the environment. On average, Eastern coal, again, is a little bit older. It's going to produce more energy per pound than coal from the western part of the United States, but these are both very profitable for companies like American Electric Power and Duke Energy, and so they're going to burn both of this. In the United States, each person consumes about 5 pounds of coal per day, and so you consume about 2,000 pounds or 1 ton of coal each year. We do have a lot of coal miners in the United States, about 2,500 mines and somewhere around 100,000 coal miners. As far as coal production, mining, and burning, coal transportation by rail and barge is by far the major cost associated with coal and coal mining practices. And so this is where the majority of the cost comes from. And when you pay your electric bill each month, you are paying a large portion of the transportation costs. So these are the major coal deposits in the United States, and you can see here in Appalachia there is a large deposit. If we go into Montana and Wyoming and Utah and Colorado and these states out in the west, you can see that we also have rather sizable deposits of coal. And in the Midwestern states we have coal as well. Along Texas and Louisiana, this is lignite coal. This is lignite coal up here. So again, we're probably not going to mine this material, at least not for a few hundred millions of years into the future, because when we burn this, we're not going to generate enough electricity. Enough profit is not going to be made. But here in the United States, at current consumption, we probably have enough coal to last the United States somewhere around 100, maybe 150 more years. The United States has the largest coal deposit of any country in the world, and so in our lifetime, it's probably a good bet that we will be relying for coal for energy production for a very, very long time. This is why we're so addicted to coal, because we have such plentiful resources. We can burn this material and manufacture electricity. We know how to do it, and this is why it's really difficult for us in the United States to get away from this type of fossil fuel. So I want you to watch this audio slideshow from the New York Times. It provides some really interesting facts about the use of coal in the United States. You'll learn from watching the video some things such as the United States has somewhere around 100 years, perhaps 250 years of coal at our current consumption rates. So if we use more of this, it's going to certainly maybe be around 100 years. If we become more conservative in our fuel consumption and use, if we use this in a more manageable way, such as things like using compact fluorescent bulbs that require less energy, we can probably bleed out this fossil fuel for perhaps up to 200 years. The United States has the largest coal resource of any country on Earth. You will see some coal-fired electricity plants. A typical 500 megawatt power plant will produce enough energy for about 500,000 homes. This produces, according to Royal Dutch Shell, the equivalent amount of greenhouse gas emissions to about 750,000 cars. Coal uses a lot of water. The way coal works is it burns, produces heat. This heat is used to boil water. This boiling water produces steam. This steam is used to turn a turbine to produce electricity. So you're going to lose a tremendous amount of water. So all coal-fired power plants have to be near a source of water, whether it's a lake or a river, somewhere where they're going to get this resource that they need. Current coal-fired power plants, when they burn that 1 pound of coal, they convert about 33% of that into electricity. And about the remaining 60 to 70% is actually lost as heat waste. We talked about this early on when we talked about ecosystems and the entropy of a system. The entropy or the randomness is always increasing. And again, when we talk about ecosystems and as you move up the food chain, you're always losing some of this energy in the form of heat waste, and that's the same thing with coal-fired power plants. If we can find a way to capture this heat waste, we can become more efficient, we can release less greenhouse gas emissions. So this is just some of the technology that many engineers are looking at in trying to develop coal-fired power plants that are not as negative for the environment. All coal, when we burn it, is bad for the environment, but if we can engineer ways to mitigate this, some people believe that this may be a better alternative than the current coal-fired power plants. Myself, I believe that we should probably use renewable resources such as solar and wind power rather than coal. But again, when you consider that the United States has the largest coal resource of any country on earth, it's very hard to get over using this as an energy source because we have so much of it, and it is very profitable for many companies.